In part 3 of this tutorial on basic processing techniques of picoSpin JCAMP data using the Mnova NMR processing software, we're going to cover the subject of phase and baseline correction. Let's start with phase correcting our spectrum. Due in part to delays between the initial pulse and the onset of data acquisition and to off-resonance effects, acquired spectra will have a mix of absorptive and dispersive signals. Your spectrum's peaks should display characteristic Lorentzian line shape, but some portion of the signal may be displaced below the baseline. You'll have to correct the spectrum by adjusting the phase of the spectrum. Phasing the spectrum is routine and involves correcting two parameters: zero-order phase, which is frequency independent, and first-order phase, which is frequency dependent. The phase correction icon is next to the FT icon on the processing toolbar, and by default it's set to automatic phasing. Once you select a non-automated option, the icon will change. In most cases, we'll want to manually phase correct our spectrum. We access the manual phase correction dialog box by clicking the scroll-down menu option on the phase correction icon, or with the keystroke Shift-P. Selecting manual correction causes a phase correction dialog box to appear. We can reposition and resize the window as needed. We can apply both zeroth and first-order phase correction interactively by clicking, holding, and dragging the left mouse button within the blue part of the window for zero-order correction, and by doing the same with the right mouse button, we can apply first-order corrections. We can also manually adjust the applied phase correction by changing values in the numerical boxes. It's rare for one to need this level of phase control, but the option is available. The center of gravity of phase correction is determined by the position of a thick blue line, and by default should be positioned on the largest signal. If it isn't present in the spectrum, or isn't on the largest peak, then simply click on the button labeled biggest, and it'll find the peak for you. You can also change the center of gravity by adjusting the position scroll bar, or by grabbing the red box at the vertical center of the line and dragging it into position. With phase correction, you want to make all your signals appear absorptive, and to restore the Lorentzian line shape and symmetry of your signals. Zero-order correction works on signals close to the center of gravity lines and is sensitive to small mouse motions, resulting in large corrections, while first-order corrections work on signals farther away from the center of gravity line and appears much less sensitive. Holding down the Control key while making phase adjustments toggles fine-tuning, thus reducing the sensitivity of the mouse action. Make adjustments to the zero-order correction first, until you're satisfied with the baseline symmetry of your signal near the center of gravity line, and then make first-order corrections until the signals farther away show similar baseline symmetry. Keep in mind that signal integration is strongly dependent on phase correction, so do a good job phasing your spectrum. If you need to, you can always touch up the phase later. When you're finished with phase correction, X out of the window. Next, we'll apply baseline correction to our spectrum. Clicking the scroll-down menu on the baseline correction icon reveals several correction options, while the keystroke B opens the baseline dialog box directly. There are a variety of baseline correction methods available, such as Bernstein polynomials and multipoint correction, and you should choose the method which produces the best results. Baseline correction in Mnova is very robust, and choosing full auto produces nice results. So if the automatic mode is already set, then just click the baseline correction icon. Otherwise, click the scroll-down menu and select full auto. You should be aware that signal integration is strongly dependent on baseline correction, so venturing into manual, multi-point baseline correction can produce spurious results. In part 4, we'll chemical shift reference our data.